welcome to your next math lesson. You might notice I've changed the setup here based on my audiovisual technician, also known as Liz. Believes the lighting is better, the angle is better, the board's a little higher. That's why I have on my heels today. I'm just kidding. I dressed up for you. I'm tired of wearing my workout clothes and my pajamas. So I'm dressed like I would go to school. You're welcome. Penny, are you ready? You ready to listen? Good girl. All right. Gray Cat's around here somewhere. I'm not sure where he is right now. All right, so we learned in Unit 7 that there are attributes of flat, two-dimensional shapes. And attributes can be defining or non-defining. So we're moving into three-dimensional shapes. And the difference between two-dimensional and three-dimensional is a shape that you can put your hand around, such as this cute, tiny little can of tomato paste used in spaghetti sauce. Came out of my pantry. Maybe you're using a lot of pantry items yourself right now. Cooking a lot. Okay, so that's the difference between a two-dimensional object, which would be flat, a piece of paper, the shapes that we learned about in Unit 7. And today we're going to talk about some three-dimensional shapes. Here's some nice drawings here that we put up on the board for you. We're going to go over those shapes and the parts. But we're going to start with a math message, and this is an actual in-action math message where we're going to do some exploring of the shapes. So I'm going to use my little table surface here to demonstrate a few things. Now, we could say this is a ball. And if she sees it, she's going to take off running. So we could say this ball rolls. Okay, go get your ball. Get your ball. Bring it back to me, Penny. Bring it back. Bring it back. Bring it back. Good girl. Bring it back. Oh, thank you. She throws it to me. So we all agree this ball does roll. Okay, we're going to put that there. We could say this box of Kleenexes, it doesn't roll. It doesn't have any curves. That didn't work out so well. Now, we could say our tomato paste can, well, it does roll in a different way. Okay, so we're going to start kind of shifting what we call these items based on their math name. And this we'll start with, again, you might say, oh, it's a ball. It's a cute little tennis ball for Penny. That's true. But in the land of three-dimensional objects, it's a sphere. Say that with me. Sphere. Sometimes students say spear, like you stab a fish. Okay, back to where we were. I had to put my glasses on too. I couldn't see. I just want you to notice I did pick the glasses that match the ink of our dry erase marker. Okay, so I was saying before I started laughing, a sphere is the technical three-dimensional name of this shape. Most of you would say, well, that's a ball also, and I'll agree with you. But for our math purposes, sphere. And that's kind of a tongue twister that students sometimes, as I said before, will say spear, S-P, instead of sf, and the F sound for PH. Some phonics right here in the middle of math. You never know what's going to happen. All right, so we realize that our cylinder, that's the name of this shape. You could say it's a can of tomato paste. I'll agree. The can did do a small roll because it has curved sides, but it has a flat face, and we're going to learn these parts in just a minute. So it rolls, but in a different way than a sphere. And our Kleenex box is the shape of a rectangle. You probably noticed that because it has a short side, a long side, a short side, and a long side. That makes it a rectangle. So this three-dimensional object name is a rectangular prism. Okay? So instead of a tissue box, we'll be calling this rectangular prism. He's our friend. And this here, you may have had these when you were small. That's K for Caden, he's in our class. P for Patrick, he's in our class. Happens to be the letters I see on here. I have an I here for Ishan. I don't think anybody's name starts with X or Z. And that's it. Then we have the number 9. So this is a cube. You might say, no, Miss Shimbop, that's a block that I played with. And I'd stack them, and then my brother would knock them down, or my sister would knock them down. But this technically is a cube, and I've drawn a cube up here on the board. I've drawn a cylinder. Oh, and this shape here is a cone. You could wear it as a hat. It looks like a party hat, right? So this is a cone used to hold frozen ice with a sweet syrup on it, snow cone. You probably recognize that. So this is a cone. That is the name of this three-dimensional object, not a snow cone paper holder. That would be the everyday household name of that item. This you might recognize. You're probably using these in small quantities in your house right now to make sure you don't run out. It's a toilet paper roll. It's a cylinder. It's just like the can. It has a curved surface and flat faces. This is called the face of the shape. All right, so let's keep going with what we're doing. Get myself in the right spot. So again, we're gonna stick to the three-dimensional name of these shapes as opposed to the household names as we keep going through this lesson. So we talk about defining and non-defining attributes of two-dimensional shapes. We can do the same thing with three-dimensional shapes. A cylinder can be big or small. Here's another cylinder. It's a little bit skinnier than our can, but it's still a cylinder. It doesn't matter what size it is or the width of it. To be a cylinder, the defining attribute is that this part of your cylinder, okay, is the face and it's flat. It's this side and this side. This is the surface, like I've labeled the surface of the cone. This would be the surface of the cylinder. It must be curved, no straight lines on a cylinder. That would be a defining attribute. A non-defining attribute would be the size of it or the color, okay? Same thing with our ball, otherwise known as a sphere. I'm not sure what Penny did with her little green tennis ball, but they can be different sizes. But to be a sphere, it's curved all the way around. There are no lines, no flat surfaces. It's simply a round shape. All right, and as far as your rectangular prism goes, there are no curves at all. It has to have flat sides everywhere. And the face is the shape of the object. For instance, this is the face of the cube because you know these are the same size. I have a couple of different size cubes, and these would be non-defining attributes. One's blue, one's just wood color, one's a little bit smaller than the other, but they are the same shape. They are a cube, just like we drew up here. So the next thing that I want to talk to you about, we'll kind of turn our attention over here to our board, and that is the surface, the face, the edge, and the vertex. Now, I'll tell you right now, you don't have to worry about learning every single one of these parts. We're just going to talk about them today, so you're familiar with them. We've already talked about corners on two-dimensional shapes, and they also exist here when you have two sides that come together. That is a corner. When you have three edges that meet, that's a vertex. Again, I'm not going to even label that one up here. I just want you to hear the word vertex. So the skin, or the outside covering of the three-dimensional objects, is called the surface. I mentioned that just a second ago. So for the snow cone holder, the cone, this is the surface or the skin, the covering of that three-dimensional shape. So we have that labeled here. And then the face of a cone, I've drawn it as best I can, pretty good. It's right here, and that's flat, okay? All right, and I have some cones maybe over here in my box of three-dimensional shapes, but we're gonna just stick with the cone I have out here for right now. All right, so if I point to all flat sides of this rectangular prism, I'm pointing to the shape's faces. They're all in the shape of a rectangle, which is how you know it is not a triangular prism, it's a rectangle prism because it has flat sides in the shape on every single face as a rectangle. All right, so if you turn to your math journal on page 170, if you have that sitting handy right now, you can open it up. I will show you my math journal page. You're going to see some pretty cool diagrams here of three-dimensional objects. Now you might notice the dotted lines that are a little bit lighter, and they're pretty much looking like they're in the background. That's to show you this is in fact a three-dimensional shape that you're looking at, not just a two-dimensional shape. All right, like if we look at this next page, these three shapes down here, they're just two-dimensional. They're just drawn flat on the page. The dots, just like I put up here on my cube, you'd have to have X-ray vision to see right through that cube, because we can't see through it on an actual object that we put our hand around. But we know these dots are here to show it is a three-dimensional object, and you know you're looking at that as opposed to a two-dimensional object. All right, so for your math work today, you're going to get some practice with three-dimensional objects. You're going to look at page 170. You don't have to do anything with that. That's a page I just showed you, and you'll see pictures of three-dimensional shapes. We're going to skip page 171. That was something we would need to do in class with some data from the whole class. It's okay that we're not going to do that. So you have math boxes on page 172, okay? And you have a home link on page 221. So that is your math work for tonight, and that is Thursday, today, whatever time of the day you're watching this video. So I hope you enjoyed a little something on three-dimensional shapes. That's all I have for you today. Hope you're doing well. I'll see you next time. Bye. You have a fish. If you're fishing, but this is